Let's start with our tree for this combat scene. So the first thing that we need to do is to basically search for a target for each agent. So let's create another agent group. So you have grid layout state machine, just duplicate this one. This one will be my enemy. Let's switch direction here. This way I have two agents that go in front one of each other. Okay, let's create the behavior tree. Let's go atoms UI, behavior tree. Let's go Paladin BT. So let's first expose some metadata to the blackboard, some of the variables we need. So the first we need the position. This is a metadata, so we need to link to the agent metadata. In this way you can read directly from the agents. The other thing is the direction as well. Vector 3. And link as well, and then we need the group ID. That is ID inside the agent group. This one is an integer, link as well, and then the ID. Integer and link. Now we need to an entry in the blackboard that store the enemy agent ID. In this way you can read the position, get direction from the agents, and so on. So let's expose one integer. Let's go target ID and let's put a -1 as the default value. This is not linked to any metadata. Now let's keep like this for now. Yeah, now let's put some nodes here. So the nodes that we need to use to search for agents is the get closest agents. So let's have a look to the parameter of this these nodes. So it needs a list of agent groups that use it to search for the closest agents. The agent ID where it will store the closest agents. In this case, it will be my target ID. So let's link directly the target ID. And here we can put some condition. So basically, the condition means that if it search for all the agents that have basically this condition valid. So in this case, I want I want to search for all the agents that has a target ID to -1. So it means that they don't have yet a target ID. This way, one agents go only to another single agent. So there are not multiple agents go attack a single agent. So this one is an integer. I want to search for all the agents that have this metadata. Since this one will be a metadata, we can link this one to a metadata as well. In this way, it will create it automatically. And here we can link the direction of my agents. So we link from the blackboard direction. And let's search a distance of, I don't know, 1000 should be fine. And then the position. Position, we need to link the agent, our agent position. So now we link this one, it's for register. Now we need to attach the behavior tree to each of the agent group. Okay, and also here behavior tree. Okay, now last thing we need to tell this node the agent group that you want search. So let's expose a blackboard key to the module. It's called agent groups. And this one will be a string array, because this one is a string array. Let's expose this one, and then we can link this blackboard entry to these attributes. So agent groups, register. So let's have a look here. I have the agent group. So this one is need to look for agent on the agent group node 1. So let's add one here, agent group 1. Instead here, this one must search on this agent group 2. Okay. So if we try to let's have a look to the metadata. So we can write metadata, target ID, both. This is still -1. So if I press play here like this, nothing will change, because obviously this one just look for one time, so one frame, then return false because it doesn't find anything, and the tree stopped to execute. So the first thing to do is to do an optional nodes, so this way convert every time to true, and then a repeat. So let's connect the repeat to the optional. The repeat, I want these three run forever, so just turn on the run forever, and the optional just return. Always basically return true. The last thing that I want to do basically of one agent, I don't want to recompute the closed agent if they already found a target. So I can put a conditional decorator here. And here I can tell switch to int, because basically I want tell to execute the child of the node only if the target ID is -1. So only if the agent didn't find a target yet. So let's switch here. The check type is equal. I want to link my target ID. This way take the value from the blackboard, not from the attribute here. I want to execute only this one is equal to -1. Now let's register. Let's have a look. Now you see this agent found the other one. Sorry. Let's display us to the ID. So in this, you see that this one look for ID and ID. So as you can see, start the target ID is -1, and then I must immediately go to the found agents. If we decrease the radius, we'll take some more time here. So let's put to 500. And now you're fine. As you can see, only this agent is finding the target, is setting the target ID, because this one is also looking for agent with the target ID to -1, but there is no agent available with this targeting ID. What we want basically is as soon an agent found a target, we want to set the target also on the other agent to basically this agent. So we want that this target ID will be 0 in this case. So what we can do is go back to our behavior tree and put a sequence node here. So the sequence just execute multiple children in sequence as long as they return success. So after this node found, so if this node doesn't find a valid target, return false, and so go back to the parent, return false, false, and repeat the option, switch back to the success, and then repeat start again. So it start to search again. But if it's one return success, then the sequence can execute another children. And in this case, we want basically set the target ID in metadata on the enemy. So let's use the set agent metadata. Okay, so now we want set the name the target ID on the enemy. That is int metadata. We want to set this as a ID of this current agent. So using an ID here that are exposed to the blackboard, so I can link the ID here. Now we need to tell this node which agent we want to write to. In this case, basically the ID is stored by inside the target ID by the get closed agents, because it stored the ID of the agent defined inside the target ID. So I can link directly the target ID here, but I need to tell that it's a global ID. Otherwise, we'll search for the group ID metadata instead of ID. So basically, should be that's it. Let's register. Let's have a look. Now it's working correctly. As you can see, the target ID, the agent with ID 0, find the target ID with the 1, and then set also the target ID on the 0. So now we have agents that basically know each other, know where to go, and know which agent to attack. So now it seems that we are all ready, but there is one small thing that we need to do. So here we have a problem if we try to execute these 3 on multiple agents on the same agent group. So if I create multiple agents here, for example, let's create 3 on the z-axis, and let's create 3 enemy. So if I press play, now you don't, you don't see what is happening, but could be a problem. Basically, since atoms can run multiple agents using multiple threads, this tree is executed by multiple agents basically at the same time. So you can end up that some agent here found the same target, because one of the agents that found this target doesn't set the other agent target ID yet, and so multiple agents can basically detect the same agent as a target. What you can do to fix this is using a lock node. Basically, let's create a lock node. So the lock nodes guarantees that the child branch is executing one agent per time. So it does, so multiple agents never execute this branch at the same times. So basically, this node basically switch to a sequence of computation of the agents for this branch instead to have a parallel execution of this branch by multiple agents. In this way, you guarantee that you are basically changing other agent metadata one agent per time, and you don't end up with multiple agents of the same group found the same target, the same agent target. So it's really important to remember to put this lock node in this case. So let's register. And now basically we have all agents finding the rich targets. So now what we can do is to basically let's increase the distance. For example, we can switch to a run mode when we found a valid target. So what we can do is to set agent metadata on my current agent. So leave the ID to -1. If you leave to -1, it will use the current ID. And in this case, I can set my state of the state metadata. I control the state machine, and we can put to a run. Yeah, one thing to remember is to go to the state machine and tell to the state machine module to set the state only at the init simulation. Otherwise, continue to override the state. So let's put the state on agent creator only on both the agent group. So you can see now just running toward each other. If we want, we can switch also the enemy to a run. So we can here copy and paste this one and to set the run not on the current agent but on the targets, and this one will be a global ID. Yeah, now we have the logic that the agents found a target and then start to run toward this. Now it's start to run, but we need to fix the direction in order to basically make the agent run towards the agents. So we need to compute the direction here. So we have the target ID, so we know which is the enemy, so we can extract the target position in order to compute a new direction. So we need a blackboard to store the target position because we are using this value by multiple nodes. So let's call target position. This one will be a position, so it's a vector 3. That's it. And now we can use a get agent metadata. And then, so we are going to store this in the target position. The metadata is the position, and the agent is my target. So basically, we are reading the position metadata from the target and store inside the target position. So if I register, we have the position. And then we can compute the direction. So we can use a compute direction nodes here. And this one will be my direction. The start pose will be my current pose, and will be my target position. So register. And now they should go basically toward each other, at least set the initial direction when you start to run to the right direction to reach the target. So our first step is done. So let's save this one as a search enemy scene, and now we move to another state where the agents basically reach the target and stop when it reached the target at a certain distance.